What are vector embeddings? Vector embedding is data represented as a vector. What is data? So data can be in four forms: text, images, audio, and video. And vectors, well, they're just a sequence of numbers that hold semantic meaning. Starting from text to vector, we have a lot of models. It's a spectrum. I'll explain the two ends of the spectrum, starting from a small model called Word2Vec and a big model called BERT. Word2Vec is trained on 5-word sentences on each side. Something like the King of France, the Queen of England, I love my cat, and uses one of two methods. Continuous bag of words, where the model is given a masked version of input prompt and has to predict the masked word, that is the blank of France, and we have a loss function around it to train it in backpropagation. If you don't know what any of those words mean, you should probably check my previous videos where I explain neural network from scratch. Basically, the ML models are trained by letting them predict something, then giving them what they should have predicted. This makes them update their weights and biases, so the next time they will predict the output with higher accuracy. The second method is called skipgram, where we use the middle word to predict the surrounding words. So here the training data is blank, king, blank, blank. What this does is it gives the word in the sentence semantic meaning with respect to the whole sentence and is represented as a vector. The closer the vectors are, the more similar they are. So here king and queen will be closer to each other than king and cat. They tried to increase the sentence size from 5 on each side to higher values so they could embed the semantic meaning of a sentence instead of just a word. They made some progress, and GloVe is the model that can do this. It can convert sentence to vectors, and later they thought they could push their luck and try to embed a whole paragraph, but realized they lost semantic meaning as the context got bigger. And then enters the paper, attention is all you need, where they came out with the transformer architecture, which could make longer sentences and paragraphs into vector. Yeah, well, the main difference between GloVe and BERT is that BERT can understand things like sarcasm and idiomatic expressions, where GloVe cannot. So when we encode "it's raining cats and dogs" phrase through the GloVe model, it actually converts the sentence "it's raining cats and dogs" into vector, but the vector holds the semantic meaning, the literal semantic meaning of cats and dogs falling out of the sky. Okay, but when we vectorize the same phrase "it's raining cats and dogs" through BERT, it's vectorized and it holds the semantic meaning that it is raining heavily. So that's the difference between the models. But BERT is a way more compute intensive model compared to GloVe. For example, using BERT to classify quote documents is like using a rocket launcher to swat a fly. It will get the job done, but it's overkill. For straightforward facts with no funky language, GloVe gets the job done more efficiently. Image to vectors, we use deep learning models like ResNet for images. ResNet is basically a glorified stack of CNN layers sprinkled with some pooling magic and clever residual connections, which helps it sidestep the vanishing gradient problem and make the deep neural network actually trainable. The most popular embedding model is CLIP from OpenAI. This is a model that people use even though they don't need it for their specific use case. For example, using CLIP to see whether a shelf at the Walmart store is empty or not is equivalent to your grandma driving a Ferrari to a supermarket. ResNet uses labels like cat, dog, chair, and CLIP uses more descriptive text to describe the image, like a picture of a cat sitting on a wooden floor. And also, instead of just using an image encoder like ResNet, CLIP also uses transformer-based text encoder for the text description because it's a multimodal. That means It integrates both visual and textual information in a unified representation space. So it's a hefty model. Just have Bill check the shelves instead of using AI, or the AI might get mad and take over the world. Now, we are left with audio and video. Well, it is simpler than you think. Audio is converted into image called a spectrogram, which is a 2D graph with time on the x-axis and frequency on the y-axis. As the audio is played, it's broken down into different frequencies over time. Spectrogram captures these changes, creating a colorful graph where each color represents different frequencies and their intensities. And as before, you can use image embedding model here since, the audio is an image now, but dedicated embedding models for audio will perform better as they're more suitable to handle audio. Some models are wave to VEC, or on the other side of the spectrum, a transformer model called audio spectrum transformer. Same logic as before. And video is just frame, and frames are just images. Well, that's all. Thank you for watching. I'll see you in the next one.